All right, so today we're going to start our final chapter, which is going to be solving quadratic equations. That's what QE stands for. So solving quadratic equations by the square root property. And a lot of us, I want to believe, already you've seen something like this before, but maybe you didn't realize that you actually get two solutions to this. So let me show you what I mean here. So if we look at a very simple example, like let's say we wanted to solve x squared minus 4 equals 0. Well, we know one of the ways we could do this is we could factor this because we definitely have difference of squares. So we would just write x plus 2 times x minus 2 equals 0. And then the zero product property, which we would just set each one of these equal to 0. And then we would solve accordingly to get x equals minus 2 and x equals positive 2, okay? Well, the other way to solve this problem, all right, which is definitely a way that students are familiar with, would be to first isolate the quadratic term, okay? So to do that, we're going to add 4 to both sides. So let me just rewrite the problem. So I'm going to add 4 to both sides. Okay, and then we would take the square root of both sides. So we would say the square root of x squared equals the square root of 4. And here is where students tend to just forget about a little important piece of information, which is if we look at the previous example, we get two solutions. And we get two solutions because we have an exponent of 2. So that exponent tells me how many solutions I should get. And notice they're plus and minus 2. Well, on the right-hand side, the square root of x squared is x. However, we got to be super careful because on the right-hand side, since we're solving, we get x equals plus or minus 2, okay? And that leads us into the square root property that we're going to be using to solve these equations today, which is, let me go ahead and pause the video and then I'll write it down and then I'll just explain it. Okay, and I'm back, and here is our square root property right here. So it says if x squared equals k, and k is greater than or equal to 0, then x is going to equal the square root of k, or x equals the negative square root of k. So with all properties, from now until if you have me for math, I always like to do an example directly underneath, all right? Because I think it's super important to see just how these properties work. Also, you're going to start to realize that mathematics is nothing more than just a bunch of conditional statements, meaning if you meet this condition, then you do this, which, to be honest with you, is what makes math super easy to learn because all you're looking for are these conditions. See, the problem is students tend to study math by just replicating problems without understanding why they're doing it. This property is why we do something. So let me show you what I mean directly underneath. If, let's say, x squared equals 25, and 25 is definitely greater than or equal to 0, like we know that. So notice, here's our condition, all right? And we meet that. We can say yes. We've met this condition. Then this is what we're going to do. We say x equals the square root of 25, or x equals negative square root of 25. We know the square root of 25 is 5. And then this one is just going to be negative 5. And that's how we get these two answers of plus or minus. So, like I said, this is the key to studying math. It took me, and I'm not kidding, it took me until my sophomore year of college mathematics to just make this connection, which is really, really sad when you think about it. All right? If you meet this condition, then you do this. And that is Math 101 right there, okay? So what I'd like to do here is just do a couple more examples, and then I'm going to show you like different problems and stuff like that, okay? So here's another example. So we're going to solve x squared minus 7 equals 0. So in this situation, remember, first thing we want to do is isolate the quadratic term. And the quadratic term is x squared, okay? So I'm going to add 7 to both sides. That gives me x squared equals 7. And then step 2, we're going to apply the square root property. Okay? So I take the square root of both sides. And in this situation, the square root of 7 is not a nice number. So you just leave it like that. But make sure you put this plus or minus out front. Okay? All right, here's another example. Okay? So we're going to solve 5m squared equals 80. All right? Now remember, you got to isolate the quadratic term, which means I have to divide both sides by 5. Now, 5m squared over 5 reduces down to m squared. And 80 divided by 5 is 16. Then we apply our square root property to give me m equals plus or minus 4. So even though we started off with a problem that looked entirely different from what we're used to, it turned out to be very simple if we understand the steps, which is you got to make sure you isolate the quadratic term before you do anything, okay? So now let's look at an example like this. Okay, so we're going to solve q squared plus 24 equals 0. Well, remember, and I'm going to write this, I'll start writing the steps off to the right-hand side here. Step 1, isolate q squared. So we'll subtract 24 from both sides. Now, step 2 would be the square root property, okay? But here's the catch with this one. When we try to apply the square root property, notice we have a negative underneath the radical. And this is not allowed. Okay? So what we would say is just the square root of 24, or I'm sorry, square root of negative 24 is not a real solution. Okay? In fact, if we were to get out our calculator, let me see if I can get out my calculator here real quick. I gotta find it. Here it is. All right, there we go. So you can see a big screen here. If I were to try to do the square root of negative 24, as soon as I hit enter, non-real answer. All right? And that's because you're not allowed to have square or negatives underneath that square root. Okay? Now, the only way that I can make these problems more in depth a little bit, okay, is by giving you more work to do first. But you have the technique already established. So if I wanted to solve 2/3 x squared plus 5 equals 17, remember step 1, we need to isolate x squared. No matter what, you got to isolate it. And notice the coefficient in front of that x squared is a 1. So what I'm going to do first, Subtract 5 from both sides. That gives me 2/3 times x squared equals 12. Then I'm going to multiply everything by 3. On the left-hand side, the 3's reduce. That gives me 2x squared equals 36. Then I'm going to divide both sides by 2 to give me x squared equals 18. So now I finally have my quadratic term isolated. Step 2, square root property. So I take the square root of x squared and plus or minus the square root of 18. That's going to give me x equals, now this is going to be plus or minus the square root of 18. But we could definitely simplify that. All right, so remember, square root of 18 is really 9 times 2, which reduces down into the square root of 9 times the square root of 2, which is 3 square root of 2. So x is going to equal plus or minus 3 square root of 2 as a final answer. Okay? So you've got to make sure you do this. All right, you've got to make sure you do this. Let's try another one here. Let's solve 5r squared minus 2 equals 34. Okay? So once again, isolate the quadratic term. Well, in this case, it's not x squared, sorry. It's r squared. So I'm going to add 2 to both sides. So 34 plus 2 is what? 36. Then I'm going to divide both sides by 5 to yield r squared equals 36 over 5. And there's nothing you could do to simplify that. It is what it is. Step 2. Square root property time. So we get the square root of r squared equals plus or minus the square root of 36 over 5. All right, and now we're going to have to simplify. So r is going to equal plus or minus the square root of 36 over the square root of 5. Let's separate them. Then r is going to equal plus or minus 6 over the square root of 5. Notice we're going to have to rationalize our denominator here. Oh, I'm running out of space. There we go. So I'll do it directly underneath here. So we're going to multiply this by the square root of 5 over the square root of 5. And that gets rid of my radical in my denominator for a final answer of r equals plus or minus 6 square root of 5 over 5. Okay? Now, the last group of problems I'm going to show you is I'm telling you, you may not believe me at first, but they are the same exact problems that we've been doing the entire time. All right? So we're going to solve the quantity of x minus 3 squared equals 16. Okay? Now, like I said, I know this looks different, and I know some of us may want to look at this and say, well, we're going to go ahead and distribute, and we're going to try to do that. You don't do any of that. And here's why. This is the quadratic term. Okay, notice it's all in parentheses. So that x minus 3, that entire thing is in parentheses. Okay? So if you go back to your definition of what we learned along at the very beginning of this lecture here, which is if x squared equals k, and k is greater than or equal to 0, then x equals the square root of k, or x equals negative square root of k. Now what we've been doing is we've just been writing it like this. x equals plus or minus the square root of k. So what I'm going to do is directly underneath, I'm going to use our example, and I'm going to substitute everything I got. So let me get rid of that circle. So like I said, this quantity x minus 3 is that entire term, and the 16 is the k. So if the quantity of x minus 3 squared equals 16, and 16 is greater than 0, so check and check. We've met the conditions. Then we're going to rewrite our problem just like this. X minus 3 equals plus or minus the square root of 16. Okay? Now, what we did, and I'll write it underneath in red. What we did is we took the square root of both sides and we put the plus or minus 16 out front. Okay? So notice it's the same exact thing. So let's go ahead and let's solve. So plus or minus the square root of 16. Well, we know the square root of 16 is going to be plus or minus 4. And then finally, I'm going to add 3 to both sides. So notice I get x equals 3 plus or minus 4. So we have x equals 3 plus 4, or x equals 3 minus 4. So x is going to equal 7, or x is going to equal negative 1. Okay? So I know this problem looked very different. All right, I'm zooming out here just so we can see it. But if you take a step back and you really just kind of assess what's going on, we did not deviate at all from our definition. It's just we got to be able to recognize that this quantity is raised to the second power is a quadratic term. All right, so let me do a couple more examples of this, and then we can call it a day. So we're going to solve the quantity r minus 3 equals 25. All right, so let's see here. What do we got? So we got the quadratic term isolated. So r minus 3, quantity squared, is isolated. That's good. So now we could do our square root property. So I'm just going to rewrite it. The square root of the quantity r minus 3 squared equals plus or minus the square root of 25. On the left-hand side, we get r minus 3. On the right-hand side, we get plus or minus 5. Now, we're going to add 3 to both sides to give us r equals 3 plus or minus 5. So I'm just going to go ahead and separate it. R equals 3 plus 5, or r equals 3 minus 5. So we get r equals 8, and r equals negative 2. Now sometimes we're not so lucky, and what I mean by that is with this problem right here. All right, so once again, our quadratic term is isolated, so that's good. We're going to go ahead and apply the square root property. Sorry, I'm just writing it out. So we get the square root of the quantity b plus 2 squared equals plus or minus the square root of 40. And here's where we're not so lucky. And I'm going to just scroll up real quick. Notice that when we did this, square root of 25 was 5. It's nice. This problem, square root of 16 was 4. That's nice. Here we got a situation where we have plus or minus the square root of 40. And that's not nice. Because what we have to do is go ahead and simplify this. So we're going to get 2 square roots of 10. Okay? But we still have to solve. So we still have to subtract 2 from both sides. So how we write our answer is just we write b equals -2 plus or minus 2 square roots of 10. And we leave it like that because we cannot combine those terms at all. Okay? So that's going to be it for this lecture video. I hope you enjoyed the square root property. All right, and I'll see you in the next one when we talk about completing the square.